Another type of triangle. Another type of triangle. We have a 45, 45, 90, which we learned about yesterday. Today we're going to learn about 30, 60, 90. So I'm going to try to draw a 30, 60, 90 over here. And they kind of look like this. And say that this angle over here is 60 degrees. And this angle here is 30 degrees. And this over here is a right angle, and that's why they're called 30, 60, 90. A lot of times they'll only tell you this is 30, and they'll tell you this is 90. Well, by using the fact that these have to be complementary to figure out that that one has got to be 60, right? So say, for instance, that this side is 10 over here. Anyone want to guess what this side is? 20. How could it be 20? It's less. Here's the trick, okay? It is 5. And the reason for that is if I were to draw in another triangle, like over here, that looks like this. Kind of reflect this one over here. Oh, it shouldn't be a vector. And then, over here. Okay, if I put a triangle over there, that's exactly like that one. And where this is a 30 and this is a 60, and this is exactly the same. This side, if I just took a copy of this and stuck it over here, what type of triangle would I have to have? Equilateral. And since this goes right down the middle, right, the median or the altitude or the angle bisector of an equilateral triangle intersects at the what? Midpoint, then this side has to be 5, because this is a 60, 60, 60 triangle, right? So this has to be 5. Now to find this side over here, I have to do the Pythagorean theorem. So I'm going to do that. I'm going to call that side B, okay? And I'm going to go 5 squared plus B squared equals 10 squared, because 10 is the hypotenuse, right? And I get 25 plus B squared equals 100. And I subtract 25 from both sides. B squared equals 75. So B is the square root of 75. But 73, I wrote 75, right? 75. And then I want to simplify that. What perfect square is in 75? 25 squared. So that can be written as 25 times the square root of 3. And what is the square root of 25? 5 times the square root of 3. Okay? So it turns out, so this is 5 root of 3 over here. Got that? Yes? No? Maybe? So let's draw another equilateral triangle. Or not equilateral, 30, 60, 90 triangle. Wait, I'm leaving it there. Hey. Okay, let's say that now this is my 30 degree. They'll shift this thing around, okay? So here's my 30, and all they give you is, say this is 8, okay? And that this is 30 degrees. That doesn't look like 30 degrees. So, it looks like B, okay? This is 30 degrees over here. All right? What do you think that what would this side have to be? 4. That side would have to be 4. And it might help you to draw in all the other angles. Now, what do you think that this side would have to be? Yes, it would be. Who said that? Noah said that. He sees the pattern. It's 4 times the square root of 3. If I did the Pythagorean theorem, which I'm not going to do, you would end up that this side is 4 root 3. So the rule is, this is on your conjecture sheet, in a 30, 60, 90 degree triangle, okay, the short leg, I believe it says, if the shorter leg has length A, okay, so this has length A, then the hypotenuse has length what? 2A. And the longer leg has length a times the square root of 3. Okay? And this is very, very, very important. Okay? See that? I'm going to pause a couple examples. Let's do another example up here where I draw another 30, 60, 90 triangles. And they like to give you all kinds of orientations. So sometimes they're upside down, sometimes they're sideways, sometimes they look like this. So say, for instance, that this side here is 7. Okay, this is an easy one. And this is your 30. What's this side? 14. What's this side? 7 square root of 3. Okay, got that? Now we're going to make it trickier. Now we're going to get trickier. You ready to get trickier? Yeah, you are. Okay. So say in this case, here's where it gets trickier. Say we know that this side is, this isn't really tricky, this is a little tricky. Say you know that this side is 11 square root of 3, and this is 60. And this is 90 over here. What would this side be? That side would be 11, and what would this be? 22, right? 11 root 3. So if this is the side opposite, you go opposite the 60. That's times root of 3. That's 11, and you double that to get that. Okay? I need a new piece of paper. So let's, oh, we could do another example. Let's cram up this paper with lots of examples. Okay? So let's do this one over here. 30, 60, 90. This is, pretend that that's a 30, 60. So this is 90, okay? This is 30 over here. Now say instead I give you the hypotenuse, and I tell you that the hypotenuse in this case is square root of 10, okay? And I say find A and B, okay? How would I do that? It's not square root of 5.
1/2 square root of 10.
Yeah, it's 1/2. Square root of 5 is not 1/2 the square root of 10, because that'd be square root of 10 divided. So A would be square root of 10 divided by 2, right? Or just 1, because I take the hypotenuse and divide by 2 to get the shorter leg. Now what do I need to do to this to get this side? Multiply by something. No, not 2. Multiply, to go from here to here, I have to multiply by the square root of 3. So times by square root of 3. Okay? So I'm going to get 10, square root of 10 over 2 times the square root of 3, which is square root of 30 over 2. And I think that's as much as you could simplify that. And so you read that just like that. Okay? So it can be tricky when you have the square roots in the wrong places and stuff like that. One more, and then you could have your own. Okay? So, whoops, I don't want that. I want a new piece of paper. And then I want that. So let's do one that looks like this, like this, like this. I'm going to say, ooh, that's so much fun. This is 60 degrees. This is 90 degrees. Now let's say that this side over here is square root of 6. Ooh, what's this side? What, Chad? You're right. This side. So to go from the short leg, from the long leg to the short leg, I divide by root of 3, right? Now don't try to go from the long leg to the hypotenuse. You really need to know the short leg first before you can find the hypotenuse. So to go from here to here, I need to divide by the square root of 3. So that's what I'm going to do. And the square root of 6 divided by the square root of 3, you can just divide out square roots like that. So this is equal to square root of 2, right? Square root of 2 over here. So what would this side be over here?
2 root of 2.
2 root of 2. Reminds me of the math root here. Whoops, not root of 3. 2 root of
Root of 2.
2 root of 2. 2 root, oh, it goes root of 2, 2 root. So that's how you it kind of gets kind of confusing when you start putting different types of numbers and square roots and stuff like that. Okay? So, for homework class, you're going to do nothing. That's